In this video, you'll learn how to add audio tracks and use the audio spectrum for audio reactive effects. To get started, let's open the included tutorial scene. This scene has a basic setup with some simple geometry we can work with. First, let's add some audio to the scene. A simple way to do this is to select the Timeflow object and click Create Audio Track. This creates a new game object with the necessary components, but we still need to select and assign an audio source. We can use one of the audio files in the example's audio directory, dragging it into the audio clip field. If we now play the Timeflow view, we should be able to hear the music. Note that the audio output may be muted in the game view by toggling the mute button. Before we can use this audio to drive animation behaviors, there's some additional setup needed first. Let's add the audio track to the Timeflow view. Here we can see the audio waveform and mute the track if needed. You can also add more audio tracks from the main menu by selecting Tools, Timeflow, Add Audio Track. But for now, all we need is one. In order to prepare the audio for animation, we first need to add an audio spectrum to analyze the audio data. To do this, right-click on the object and select Add Audio, Audio Spectrum. This automatically selects the audio source on the object as input. However, it is also possible to use the scene's audio listener for processing global audio or using an external audio device as input, such as a microphone or line in. Please see the example scenes for demonstrations of these setups. For this demo, we'll be using the default audio source as input. We can then further adjust the settings below. You may use either the left or right audio channels or full stereo input. In most cases, using the left channel is optimal. The sample rate should match the audio settings for best results and is set automatically. The spectrum window defines the type of calculation used for analysis and is provided by Unity's audio engine and covered in further detail in the Unity documentation. One helpful tool to visualize the audio data is to enable Graph in Game View. Then whenever we play the Timeflow view, the audio spectrum is displayed over the game view. This is only visible in the Unity editor as a tool to inspect and configure audio. We can now go through the different spectrum analysis modes to compare outputs. The list ranges from the simplest computation to the most complex. When deploying to devices with limited resources, you may want to select one of the simpler analysis modes for optimal performance. However, for now, we'll use the Blackman-Harris mode for the best quality. The resolution defines how many samples are gathered for analysis and must always be a power of 2 value, which is enforced automatically. This value may be increased for higher resolution in the spectrum, however, we can leave it at the default for now. The volume option may be enabled to output the detected level in decibels or RMS value to a separate channel. This is a read-only value for reference or to link with other channels to drive animation behaviors. When volume is enabled, it is also displayed as a green bar on the right-hand side of the graph in the game view. Similarly, pitch detection as frequency may also be output as a read-only channel. When enabled, the dominant frequency and musical note detected is displayed in the upper left corner of the graph in the game view. For this demo, we won't be using these features, but you may learn more about them in the documentation. Now that we have our audio spectrum set up, let's start adding some audio sample behaviors. First, let's select the samples object and add it to the Timeflow view. Since we want to assign a sample behavior to all 3 of the objects, we can select them and right-click to add audio sample. This adds the audio sample behavior to each one. Let's select Sample Low to go over its settings. The audio spectrum is automatically detected in the scene and assigned. The mode setting determines how samples are combined over time, either averaging their values or using the maximum spike in audio detected for any given time range. Which mode you use depends on the audio and your personal preference. Generally speaking, average produces smoother results while maximum is more dynamic. The frequency range determines the sample area in the audio from low to high frequencies. The audio spectrum is logarithmic, ranging from 0 to around 24 kHz. Since the sub-bass and kick drum are typically below 300 Hz, we can set the frequency range from 0 to 300 to capture the low end. For now, we can leave everything else at default values. Let's move on to sample mid and set the frequency range from 500 to 2000 to capture the mid-range. One helpful tool when working with ranges is to click the Show Graph button while playing the Timeflow view. This displays the audio spectrum in the game view, isolating the frequency range, making it easier to see the data and adjust the values as needed. We can also adjust the threshold, acting as a gate to filter out any low-level noise. We can then do the same thing with sample high and set the range from around 2500 up to 10,000. These ranges are just approximations and may be refined later. You may also add more audio sample instances to map additional frequencies. For a more advanced setup, please refer to the scenes included in the examples. Now that we have our audio samples prepared, let's go over a few other settings. If you'd like to use an audio sample to drive a shader effect, you can enable Set Shader Property. This sets the value of a global shader property affecting all materials using that shader. For example, the material on this object uses shader graph and defines the global value emission amount. In order for it to work as a global property, exposed must be unchecked. We can then copy the reference name and paste it into our property field. And we can see now that the audio amplitude is affecting the emission color. Using this technique, you could create any number of variants and global shader properties to drive audio reactive material effects. And lastly, we have Used Baked Data. This option may be used for pre-recorded audio to compute and save amplitude information instead of processing it at runtime. Baking audio data isn't needed for runtime use. However, it is required when rendering to disk, since audio analysis cannot take place while rendering frame by frame. Using these buttons here, you can easily bake individual audio samples, or all of them at once. This uses the work area if enabled, otherwise the full duration of the timeline is used. Press Start All to begin capturing audio data for all audio samples in the scene. Normally we would let this play all the way through until it stops automatically at the end. Though for now we can press Stop All to interrupt the process. Now when playing back, as long as Use Baked Data is enabled, the amplitude values are provided by the baked data only, with no audio processing being performed. Since we don't need baked data right now, we can press Clear All to erase it and turn off baking for all audio sample components in the scene. That concludes this tutorial on audio tracks and audio sampling. Please refer to the documentation links in the video description below for further information. Next up, we'll go over using audio reactive behaviors.